Not all hazards are big. Some of the most damaging risks in the workplace come in the smallest packages. They don't scream danger. They don't come with flashing lights or warning signs. They look harmless, familiar. Sometimes they even seem well-designed, until your body tells you otherwise. This is the world of small tools, and the big pain they can cause. Let's begin in Manchester, England. Alison worked at a packaging plant. Her task was simple: open cartons, remove inner trays, and repack items using a handheld tape dispenser. She used the same box cutter and dispenser all day. The cutter had a sleek, slim metal handle. No padding, no contour, just a straight grip. Within months, Alison started experiencing numbness in her ring and pinky fingers. At first it was just at the end of the day, then it lingered into the morning. She was diagnosed with ulnar nerve entrapment, caused by prolonged pressure and vibration from tools that didn't fit her hand. It was the size of the handle, the angle of the wrist, the lack of support, the repetition. And it wasn't just her. 3 others on her line reported similar issues within the year. The company conducted an ergonomic review. They found that the tools were designed for average male hand dimensions. Most of the workforce was female. The result? Mismatched grips and poor posture. Tool size, handle shape, grip texture. These aren't minor details. They're fundamental design elements that directly affect how the body interacts with the task. An oversized grip can force the fingers into overstretching, causing strain with every use. A handle that's too narrow can increase the need for excessive grip force, overloading the smaller muscles in the hand and wrist. A slippery surface demands constant pressure to maintain control, tiring the user faster. Even the angle of the handle, whether straight or contoured, can either support a neutral wrist posture or contribute to carpal tunnel compression. When these features don't match the task, or the worker, the result isn't just inefficiency, it's injury waiting silently over time. That's why proper tool design must start with the human body, not the manufacturing mold. Across the globe in Malaysia, Arif worked in electronics assembly. He used tweezers and micro screwdrivers to place and fasten delicate components. His tools were precise, but unforgiving. The screwdrivers had hard, narrow shafts. The tweezers required constant pressure from his thumb and forefinger. By his second year, he could barely make a fist. His thumb joint was inflamed, and his grip strength had dropped by nearly half. Doctors diagnosed him with tendonitis in multiple finger tendons. His injury wasn't due to force. It was due to duration, posture, and contact stress. The company replaced his tools with versions featuring cushioned handles, wider grips, and spring-loaded tweezers to reduce effort. Arif's pain gradually improved, but he never regained full strength. And while Arif's story is about microelectronics, the exact same patterns emerge in medical labs, artisan workshops, and even beauty salons, anywhere hands work small, fast, and with repetition. In a veterinary clinic in Dublin, Emma, a technician, developed intense wrist pain from using a pair of straight-handled nail trimmers on pets. The grip was awkward, the force needed high. A simple switch to curved ergonomic clippers reduced the effort, and the pain immediately. But Emma's injury had already progressed to the point of needing physical therapy. We often underestimate the cumulative trauma caused by tool design. Look at any maintenance crew, and you'll find tools with narrow metal grips, screwdrivers with thin plastic handles, pliers that require high force. Many of these tools were designed decades ago, before we understood the long-term impact of design on muscle and tendon health. And yet, they persist. In a small bakery in Montreal, 2 bakers developed similar wrist injuries just months apart. The culprit? A pastry bag with a poorly angled nozzle that required a twisted wrist position for piping. The bag, which had been used by generations of pastry chefs, seemed harmless, just another part of the daily routine. But its rigid plastic nozzle and lack of ergonomic grip meant that each swirl of frosting, each line of piping, was done with the wrist bent unnaturally and the forearm tensed. Over time, this constant repetition and awkward positioning led to inflammation in the wrist tendons and early signs of carpal tunnel syndrome. Neither baker had reported the pain at first, brushing it off as normal strain. It wasn't until one of them dropped a bag mid-shift, her hand simply giving out, that the issue was taken seriously. An ergonomic assessment revealed that switching to piping bags with rotating nozzles and contoured grips could drastically reduce the angle of wrist deviation. After implementing the change and incorporating hand-stretching protocols during prep time, the bakery saw no further wrist injuries for the rest of the year. After an incident report, the bakery brought in adjustable nozzle piping bags and trained the team on alternating hand use and grip changes. Injuries dropped, but the lesson was clear. The smaller the tool, the more often it escapes scrutiny. In Japan, a furniture assembly facility found that their cordless drills, used thousands of times per week, were causing palm bruising and carpal tunnel symptoms. Workers were unconsciously over-gripping to stabilize the tool. A redesign introduced rubberized, contoured handles and shorter trigger throws. The result? Fewer complaints, better productivity, and less strain. And then there's the world of agriculture. In Argentina, field workers used traditional shears with straight metal handles for pruning. These tools were heavy, stiff, and required a strong, consistent grip, often over many hours without break. The handles offered no padding, no contour, and forced the user's wrist into a slightly extended position with every snip. Over time, these repetitive actions began to take a toll. Multiple workers started reporting symptoms like forearm pain, tingling in their fingers, and numbness along the outer edge of their hands. The pain wasn't sharp, it was dull, persistent, and grew worse with each harvest season. At first, they blamed the workload, the heat, even age. But when several workers required medical treatment for tendonitis and nerve compression within the same 6-month span, the company could no longer ignore the pattern. A full ergonomic evaluation revealed that the real culprit was the tool itself. The outdated design, inappropriate for the demands of modern agricultural productivity. Once again, design was the hidden factor. The solution came from an unlikely place, an ergonomist studying musical instrument grips. They collaborated with the tool supplier to introduce offset-handled shears with spring returns and rubberized, non-slip grips. Injuries declined. Efficiency rose. Workers kept their hands healthier, longer. Or in Thailand, rice workers using sickles suffered thumb and forearm pain at alarming rates. The wooden handles absorbed little vibration and required awkward positioning. A research partnership between a local university and agricultural cooperative led to the design of a curved, grip-balanced sickle with a textured rubber handle. It was a simple change, but it made harvesting significantly easier and safer. So why do poor tool designs persist? Because we mistake familiarity for safety. We assume that if a tool is common, it must be safe. We assume that if we've used it for years, it can't be the problem. But pain doesn't care about tradition. Tendons don't recognize nostalgia. Small tools can carry big consequences. And it's not just about replacing them. It's about choosing the right tool for the right hand, for the right task. Ask yourself, how often do you have to grip tightly? Does the tool force your wrist into an angle? Does it fit your hand or someone else's? Are you left-handed but forced to use a right-handed tool? Do your fingers feel sore? Your knuckles ache? Your palm go numb? These are the signals. These are the clues. A study in the United States found that customizing tool selection to user grip strength and hand size reduced reported musculoskeletal discomfort by over 60% in certain manufacturing roles. But those interventions only happened when someone stopped to ask the right questions. Every hand is different. Every task demands something specific. If we want to prevent injury, we need to rethink the little things. Inspect your tools, ask for input, trial alternatives, and never ignore discomfort just because the tool is small. Some companies are now implementing tool fit testing, much like PPE fit tests, to ensure proper hand-to-tool matching. It's not a widespread practice yet, but it's an innovation worth watching. And safety committees are beginning to prioritize hand strain and grip-related fatigue as high-value topics. This isn't about luxury, it's about prevention. Because small tools can change lives, for better or worse. Let's choose better. If you've ever experienced tool-related discomfort or injury, share your story. What worked? What did you wish you'd known sooner? Your insight could be the redesign someone else desperately needs. Stay alert, stay equipped, stay safe.